Hello friends, in this video we'll go to see what is reactance, resistance and impedance and what is the difference between reactance, resistance and impedance. First, let's see what is reactance. Reactance is a property that opposes a change in current and is found in both inductors and capacitors. Reactance is nothing but we know inductors and capacitors are current sensitive elements, which means inductor oppose the sudden change of current and capacitor oppose the sudden change of voltages. If we apply suddenly a current, then our reactance present in both the inductors and capacitors. That's why if we suddenly change the currents or voltages, then it's not in steady state, it is in transient state. That is nothing but the reactance. Reactance is nothing but the opposing property of a current of inductor and capacitor. That is written here. Reactance is a property that opposes a change in current and is found in both inductors and capacitors. Here reactance is only present in inductors and capacitors. Let's say this point. It only affect changing current. Reactance is specific to AC power and depends on the frequency of the current. Okay, let's see here. If consider this is the AC current, alternative current, and this is a DC current. If we apply the DC current to the inductor and capacitor, DC current means there is no fluctuations. It is a AC current, alternative current, it is a DC current. If we apply DC current, this is direct current. If we apply DC current to the inductor and capacitor, there is no change in inductance and capacitance values. There is no reactance because in this current there is no fluctuations. If fluctuations are there, then current is changes from one point to another point. Then only the reactance is present in inductance and capacitance. If we apply direct current to inductor and capacitor, then there is no reactance. If we apply direct current, then reactance equal to 0. Remember that point. When we apply alternative current, this is our point. Alternative current means AC. When we apply AC to inductor and capacitors, then a reactance will occur. Reactance is nothing but opposing property of a sudden change of current. Here observe, here current is one value and when falls to this current is one value, like that. Okay, I think you have understand. Next, I already told you reactances are two types. One is inductive reactance, another one is capacitive reactance. First see inductive reactance. Inductive reactance is directly proportional to the frequency of current. Here observe, this is the AC current. It is have some frequency. According to Indian currents, AC currents have 50 Hz frequency. Okay, that's nothing but this AC current have some frequency, that is 50 Hz. This 50 Hz frequency is directly proportional to the reactance in the case of inductive reactance. Okay, inductive reactance is directly proportional to the frequency of the current. If our frequency increases, then inductive reactance also increases. If the frequency decreases, then the inductive reactance also decreases. This is the graph between the reactance. It is inductive reactance. It is the graph between the inductive reactance and the frequency. If the frequency increases, inductive reactance also increases gradually. Okay, here one more point is there. Reactance is always denoted by X. Remember, reactance is always denoted by X. Here in case of inductive reactance, put prefix as a, not a prefix, suffix as a L. XL is nothing but inductive reactance. Here see, XL equal to 2 pi FL. 2 pi F is, here inductive reactance is nothing but XL equal to 2 pi FL. F is the frequency of the current, L is the inductance. This is the formula for finding the inductive reactance. Next see capacitive reactance. Here see capacitive reactance. Capacitive reactance is inversely proportional to the frequency of a current. In case of inductive reactance is directly proportional to the frequency of a current. In case of capacitive reactance is inversely proportional to the frequency of a current. Let's see the graph between the reactance and the frequency in capacitor. Here observe, frequency is increasing but reactance is decreasing. When frequency increasing, reactance decreasing. This is about capacitive reactance. Capacitive reactance is denoted by the Xc, and capacitive reactance is calculated by using the formula Xc is equal to 1 by 2 pi Fc. F is nothing but the frequency of the current, C is nothing but the capacitance of the capacitor. This is about reactance. Next, see resistance. Here see resistance. Resistance is nothing but the opposing nature of a current. Okay. Here see the definition for resistance. Resistance is the measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms. This is nothing but, if we have a resistor in our circuit, then this resistance is opposed by the applied current. If I apply current I to this resistor, then this resistance value is opposed by this current. If the resistance value is more, suppose this resistance value in terms of mega ohms, then the current, I think almost zero current flowing through this branch, because this resistance is opposed to the applied current. How to find the resistance? Resistance means R is equal to V into I. V is nothing but voltage across the resistor. I is nothing but current passing through the resistor. Okay, this is about resistance. Next, see impedance. Impedance is denoted by the letter Z. Impedance is the combination of reactance and resistance. In previous paper we see reactance, and here we have resistance. The combination of both reactance and resistance is nothing but the impedance. Impedance also, the units of impedance is also a ohms. Okay, this is about reactance, resistance and impedance. Thank you for watching this video.